Today's lesson is on combinations. A combination is a group of items taken without regard to their order, where a permutation problem involves situations in which order does matter. So the differences between permutations and combinations. Now, combinations we said where order doesn't matter, and permutations is where order does matter. In both a combination and a permutation, the first condition are that the items are selected from the same group. The second condition is the same as well. No item is used more than once. But the third condition is where it differentiates a combination versus a permutation. So for combinations, the orders of the items makes no difference, whereas for permutations, the order of arrangement does make a difference. So let me give you an example. An ice cream shop offers 12 assorted flavors of ice cream. One of its items is a bowl consisting of 3 flavors, each a different flavor. How many such bowls are possible? Now, condition 1 is satisfied because we're talking about the same group of 12 items. All of the ice creams being pulled from the same group. When you're picking your flavors, you can only use each flavor once. And the order in a bowl doesn't really matter. Which one is put on the left versus the right, front, back, it's in a bowl. It's all mixing together. It doesn't really matter. When you take your spoon, you can eat it in any order you want. So in this case, order doesn't matter in a bowl, okay? And then this is a combination because the order doesn't matter. Now, the other example is an ice cream shop offers 12 assorted flavors. Okay, so that's condition 1. They're selected from the same group. One of its items is a stacked ice cream cone, each a different flavor, so that's condition 2. In your preferred order, how many such cones are possible? Because we're talking about an ice cream cone, the one on top does matter versus the one on the bottom because you're going to have to eat them in a different order. So in this case, order matters, which means it's a permutation. Okay, so we're going to take some time to determine if each of the following situations is either a permutation or a combination. We're looking for if order matters or if order doesn't matter. Medals are given at a race for first, second, and third place winners. There were 30 people running in a race on Saturday. How many different outcomes are possible for these 3 positions? So just looking at, does order matter? Yes, it does. And the reason orders matters is because it's a race. We care about who comes in first. If order matters, that's going to be a permutation. The next example, how many ways can you select 6 free DVDs from a list of 200 DVDs? So does it really matter which one you put first on the order form? I don't think so. You're going to get all 6 in the box. The order doesn't really matter here. So in this case, order does not matter. And therefore, this is a combination. Next, we have a committee of 20 students to be formed to decide on the new mascot for the new school. There are 400 students in the school. How many different committees could be formed? Well, if you think about a committee, is there one person more important of another person on a committee? No. Does the first person chosen make any difference between the last person chosen on a committee? No. On a committee, everyone's working together, so order not matter. Therefore, this is a combination again. Next, we have the math club is voting on a president, vice president, secretary, and treasurer. There are 12 members of the math club. How many different presidencies could be formed? Well, in a presidency, the president has a different job than the vice president, which has a different job than the secretary and the treasurer. So the order in which these people are selected matters. And because the order matters, this is a permutation. Now, the way I remember permutation and combination is committees versus presidencies. If we're talking about a committee, that committee starts with C, and so does combination start with C. So committees are where order doesn't matter. So this is our committee example. Committee, combination. Both start with C's. Whereas the math club is voting on a presidency, right? Presidency is going to be a permutation, and those both start with the same letter. So that's one way I remember. Committees, the order doesn't matter. It's a combination. Presidencies, the order matters. It's a permutation.